Okay, this is chapter 10.2. We're going to solve equations with variables on both sides. So a variable on both sides is something like this. X is equal to x. If x is equal to x, if x is 5, then 5 is equal to 5. That's really how it works. But sometimes we have other things that happen and we have to get our variables together. We still have to do that thing where we combine like terms. We've got to combine like terms. So if we have a sample problem that looks like this, negative 4y is equal to 9 minus y. Notice that we have a y on both sides, and we have to get those together. So we have a negative 4y, and we have a minus y, which is the same thing as like a negative 1y. But we don't write the 1, we just write negative y, but it's worth 1. And we can go either way. We're going to do the opposite function. We could add 4y to both sides, or we could add y to both sides. In this case, I want to add y to both sides because it's going to move this y over to this side of the equation. So I'm going to add y because a negative y plus y is 0. And I'm going to add y. The opposite of subtraction is addition. And then I get a new problem. So negative 4 plus 1 is negative 3y is equal to 9. So this is we're combining our like terms, and now we're going to do the opposite action. Negative 3y is negative 3 times y. So when we're going to multiply, we want to divide. And negative 3 divided by negative 3 is 1. And 9 divided by negative 3 is negative 3. Therefore, y is equal to negative 3. So this is sort of step 1. Write the problem and combine like terms. It's kind of this little second part of this. And then the third step is to do the opposite. If we're multiplying, we want to divide. If we're dividing, we want to multiply. If we're adding, we want to subtract. Move it all around so that the y is by itself. Now if we put that back in, y is negative 3 up here. Negative 3 goes in for there, and negative 3 goes in for here. So negative 4 times negative 3 is positive 12. I'm going to write this over here. Positive 12 is equal to 9. And what is minus y? If y is negative 3, that's like 9 minus a negative 3, which is just like 9 plus 3. And 9 plus 3 is 12. And we can see that we have a good equation here. It worked out nicely. Okay, let's try another one or two of these just to make sure. Let's look at negative 5x is equal to x plus 12. We're going to do the same thing. We have to get our x's together. So I'm going to subtract this x from both sides. See, this just says x, but it is really a positive x. So a positive x and a negative x comes out to 0. And negative 5x minus x ends up being negative 6x. Combining two negatives together, it gets more negative. Alright, so negative 6x equals 12. And the next step is to divide both sides by negative 6. Because we want to get this x all by itself. And that does that there. 12 divided by negative 6 leaves x on one side and negative 2, because 12 divided by negative 6 is negative 2 on the other. Okay, we'll do another one just real quick, because it seems like you might need to see a few of these happen. This is a z. I usually put this little cross on the z, just so we can tell that it's a z and not some sort of 2 or something like that. Okay, so 15 take away 4z plus z equals negative 8. Now this time I've got numbers on both sides. I'm going to have to get them together. And I've got letters on both sides. I'm going to have to get them together. So it might be that I'm going to want to go this way with my letters and this way with my numbers. Does that make sense? I'm going to go ahead and we'll back out because you don't need to actually see those arrows there. But I'm going to add 4z to both sides. That gets rid of these 4z's. That leaves me 15 is equal to z plus 4z is 5z minus 8. Now I've got my z on one side, but I've got my numbers still apart, so I'm going to add 8 to both sides. the opposite of minus 8, leaves 0. 15 plus 8 is 23, equals 5z. That makes sense? Now I want to divide both sides by 5 so that I get the z all by itself. Now, our previous problems always had our letter on the left side of the equation, but our letter can be on the right side. It doesn't really matter. 5/5 is 1, and 23/5 ends up being, I'm going to put a little arrow here, 23/5. 5 goes into 23 4 whole times with 3/5 left over. That works. You could also use a decimal, or you could probably even just leave it as an improper fraction like that. Equals z. So let's leave it as an improper fraction, and we'll switch it around just to let you know that it's okay if you put the z first. Z equals 23/5. This is a good answer. So is this. These are both the same. So think about that for a second. Okay. Now the distributive property is that second thing that we're going to talk about. That we did that in 10.1 as well. This is a little more complicated because we have fractions involved. -4 times 7/2 x plus 1, all of these in parentheses, is equal to 2 times x minus 4. That doesn't look very good. It's supposed to be an x. Okay, now the distributive property, hopefully you remember, is where I multiply this and this. The -4 times each of these, and the 2 is going to be multiplied times each of these. So we'll do that really quickly. -4 times 7/2. You could kind of make it like 4 ones. And there's an x. So all of those stay together. -4 times 1 is going to be, not positive, it's going to be -4. Equals 2 times x is just 2x, and 2 times a -4 is -8. Starting to look like something. Here, 4 ones times 7/2 is 28/2. Or I could actually just simplify first, change that to a 2 and that to a 1. 4/2 is the same as 2 ones. And 2 times 7 is 14. That is a -14 over 1. Minus, oh, there's an x there. There's the x. -4 equals 2x minus 8. So now we just kind of simplified that little bit for this part. But now I want to get these together. I'm going to go ahead and add 14 to both sides because I like to add better. 14x to both sides, so this cancels out. That leaves me -4 is 16x, because 2x plus 14x minus 8. All right, now again we're going to switch it over. We're going to add 8 to both sides because I like to add. -4 plus 8 is +4. Those cancel, go away. So 4 equals 16x. And the next step would be to divide both sides by 16, because you got to get that done. And 16 over 16 is just 1, so that leaves you x all by itself. And 4 over 16 is the same as 1/4. So our answer is actually x is 1/4. Okay, that's it. One more sample distributive property question. Let's do this. -3, all multiplied by 1 minus x, parentheses, ties that together, is equal to 1/2 times 2x plus 1. All tied together. So this 1/2 is times both of those things. Let's make sure. I'm going to keep showing you that because it's important. You got to make sure you see it. -3 times 1, -3 times -x would be -3 plus 3x, because -3 times -x is positive. And 1/2 times 2x is equal to 2 halves. 1/2 times 2 is just 1. So it just gives you x. And then 1/2 times 1 is 1/2. Then we're going to just go ahead and add 3 to both sides because I like to add. Plus 3 plus 3. Those disappear. Oops. I just did something a little crazy. Alright, this combines with this. I just tried to combine it with the x. That doesn't work. I have to combine my x's. These are both positive, so I'm going to subtract x this direction. Those disappear, and I get -3 plus 2x, because 3x minus x is 2x, equals 1/2. Now I'm going to add 3 to that, and I'm going to add 3 to that. Negative 3 plus 3 is 0, so we get 2x. Positive 2x just as 2x. And 1/2 plus 3 ends up being 2 and 1/2. And that works for me, although it looks like we're going to have to change that to an improper fraction. They never make it easy for us, do they? 2x is equal to 5/2. And then we're going to divide both sides by 2. And when you divide by a fraction by the number 2, that's a little complicated. So I'm going to show you how to do that. When you divide by fractions, or you divide with fractions, you want to multiply by the reciprocal. I know you remember that. So x is equal to 5/2 times, instead of 2, it's going to be 1/2. So that's going to equal x is 5/4. And 5/4 is an improper fraction. You could probably leave it like that, or you could change it to x is 1 and 1/4, and that would be just fine, which is half of what 5/2 is. Either of those are good answers. Okay, kind of crazy, I know. All right, enjoy this one.